So now let's use our TI-83 to take a look at some information from this chapter. So what we're asking is, as boys' ages increase, is there a relationship between what happens to the boy's height? So this is an example of bivariate data. We have an age and a height, and we want to see if we're able to find a relationship between the height and the age. So the first thing we're going to do is enter our data into our calculators. So we're going to hit Stat, and we are going to hit Enter. And in list 1, we've got birth, which is 0 ages. We have 2 years, 0 years, 2 years, 3 years, 5 years, 7 years, 10 years, and 14 years. Okay, and then we're going to go over to L2. We are going to put in these heights, 50.8, 83.8, 91.4, 106.6, 119.3, 137.1, and 157.5. Okay, so now we have all of our data in. So when I look at this data like this, it does seem like there might be some sort of a relationship between the idea of boys getting older and getting taller. But we need to check it out statistically and see if this is actually the case. So what we are going to do is we are going to calculate our linear regression. We're going to go to Stat, over to Tests, and then you're going to go down and you're going to find one that says Lin Reg Test. So then you're going to hit Enter. The X list is L1, Y list L2, frequency 1 does not equal 0, regression equation, and calculate. So highlight calculate and hit Enter. This is going to give us a whole bunch of information. Notice that we start off with y equals a plus bx. It gives us our a value right here of 65.0876. Then it gives us our b value of 7.0948. And our r, remember our r is our correlation coefficient, and it's 0.9761. So just a reminder, we've put our data in L1 and L2. We're told that the y-intercept, the a value, is 65.0876. The slope is 7.0948, meaning that every year our expected growth in a boy is about 7 centimeters. The R value, the correlation coefficient, is 0.9761. So once we have this, then the first thing that we want to do is we want to go ahead and graph it. So we're going to graph it by hitting second and stat plot. We want to go ahead and select one and hit enter. And you can see that we want to turn this on. Our type is the scatter plot. We've got L1 for the X and L2 for the X. So let's hit enter. And then what we want to do, so we were just here, we want to adjust the window. So we're going to adjust the window and we're going to have the age go from 0 to, let's say, 30 years old. Scale of 1. And then the height, 0 to 300. And let's just do a scale of 50, and I'll show you why in a minute. And then you're going to hit graph. So we can take a look at this scatter plot, and we can see that it certainly does look like there's a relationship between X and Y. As X increases, Y tends to get bigger also. So certainly we see a relationship. Now, if I wanted to draw the least squares line, the line of best fit, I could draw the line that we calculated before. So let's do that now. So in order to do the line of best fit, you're going to hit y equals Then you're going to hit the VARS button. Now you could just manually enter in the equation, but this will pull it from the memory. So variables, we're going to go to 5 statistics. We're going to go over to EQ equations and the regression equation 1, hit enter. And what that's done is that's pulled the equation that we calculated earlier into there. And then when we hit the graph button, there you go. So now the line is going through, and I can see this is the regression line or the line of best fit or the least squares line. So let's say I want to figure out how tall I expected a 25-year-old man to be. Well, we might be tempted to go over to 25 and put 25 in for X. And we can do this, we can look at the table. So if you hit second and graph, in yellow it says table above it, you'll see this table. And if the X is the age, so at age 25, we'd get 242.46 centimeters. So that would be the estimated height. Well, for those of you who are proficient on the metric system, you're probably realizing that this is a ridiculous number. It's ridiculous because about 243 centimeters is almost 8 feet tall. If we were to go down to, let's say, 70-year-old man, then the Y value or the height would be even taller, and this doesn't make any sense. So there's a real danger to using the regression line. And what you need to make sure is that when you use the regression line, that you're only using it within the minimum value for X and the maximum value for X. Let me go back to the graph. So the minimum value of X and the maximum value of X. So we could predict the age of an expected height of a 12-year-old because that's within our data. So we could go back to the table and we could expect that this estimation for a 12-year-old, about 150 centimeters, would be the expected average height. We could do it for a 9-year-old because our data is from 0 to 14 years of age. We can't use it to predict the age of a 20-year-old or even a 15-year-old because that's out of our range. So this is how you can graph linear regression, get a look at some of the statistics and analyze some of the data and create a scatter plot and a chart.